Yes, I do. This is a new one. All right. So network is really frustrating us, and we're very sorry for this. Next time we'll plan for a more robust network. We will not rely on the usual or the local nets. It's really frustrating myself. Like I I feel more frustrated than you are, believe me. So let's just see what we can do. Let's just see what we can do. So there's a question I wanted us to we're supposed to do on specific capacity. Huh? Okay, let me check. So the question we're supposed to do here, and yeah, I'm hearing myself. Hmm. So let's just finish this on this. All right. That this glitches is beyond our control, so that's why it's like this. So if you're there, please let me know. Let's finish this. All right. So apologies for this. Apologies for this. It's beyond my control. It's beyond my control. Just join the new link if you're in the group. All right. So let's just solve that number one. Yes. Hmm. Okay. The first question, which is what we're going to solve, and then I will give a very important announcement. The question says, how long does it take a 750 watt heater to raise the temperature of 1 kg of water from 20 degrees Celsius to 50 degrees Celsius? This question is a very interesting one because we are told a water heater, a heater is used inside water, and you have to find the time it will take for, because the electric energy in the heater, the electric energy is given in form of IVT. The electric energy in the heater is given in form of IVT. And IVT is power times time. Where you're seeing power is IV. This heater is inserted into the water. That means that heat lost by heater as heat gained by water. Heat lost by heater is in terms of IVT, which is power times time. Heat gained by water is in form of MC delta theta. The power is given as 750 watts times the time. How long is what you're asked to find? MC delta theta, the mass of water is 1 kg times specific capacity of water is given as 200. Delta theta from 20 to 50. Theta 2 is 50 degrees Celsius. It's not necessary to convert it. Theta 1 is 20 degrees Celsius. So delta theta is theta 2 minus theta 1. So that is 50 minus 20. So that is 750T equals to 1 times 4,200 is 4,200 times 50 minus 20, that is 30. To find T, I'll divide both sides by 750. So from here now, I will now have that 750 cancel 750 such that T equals to 0 cancel 0. 420 times 30 all over 75. So my T will be equal to 168 seconds. So my answer is C. So we have successfully solved that question on specific heat capacity. I know that many persons are not here on this particular link because I had to create a new link to accommodate, to compensate for the issues that we had. So, and these challenges that we are facing is beyond my control. So, Chimamanda, welcome back here. Welcome back here. And I sincerely apologize for I'm very sorry for that. It's beyond our control. All right. So, Mighty Ekanem, thank you for being here. So, Mighty Ekanem and Chimamanda, that you are here, were you able to understand the question I just did on specific capacity? Were you able to follow? Can I hear your thoughts? So I'm waiting to. So I would like to drop a very important announcement. I know that many persons are not here. I would still have to make a short video and on that. All right. Our target was that we close the class by 11 p.m. We're supposed to close the class by 11 p.m. And unfortunately, we have not been able to do so much because of the network issues that we have. I sincerely apologize for that. And I feel bad that we could not. I feel bad that we could not treat any question in mathematics. Mm. I really want us to keep to time because I don't know your schedule. I also have my schedule. In fact, I have another class I want to catch up with. All right. So the announcement is this. The announcement is this. Who knows? If we decide to stretch this class till 12, who knows? Maybe network will frustrate us again. For vibrations in strings and pipes, I'm going to release a video for vibration in strings and pipes next week. For integration, maybe I will have to make a video based on the questions I have for integration and post it in the channel next week. But we will not have to continue at this point because we are supposed to end by 11 o'clock. I know we didn't start on time, and even when we started, the network did not allow us. So please bear with me. I sincerely apologize for the glitches, the hitches that could not allow us to make so much progress. Believe me, it was beyond my control. I did what I could to make sure that was avoided. Maybe my best was not good enough. So I'm going back to see how that could be improved as we prepare for the next live class. Thank you so much. Thank you so much for being here. We have to end at this point in time. Chimamanda, thank you for following us. Elijah, thank you for following us. All right. Okay, you have shared it. So should we continue? Should we continue? Should we continue? My fear is not that I'm tired. My fear is continuing this class, and then network app gives us issue again. So should we continue a little bit? Oh, Udo 6 asking me why. This question is giving me energy. It's like you want us to continue. All right. I'm scared of network. That's why I said what I said, right? So please let me know your thoughts. Please let me know your thoughts. Should we move to maths? Should we do something in maths? What do you think? Because network is frustrating us, man. What do you think? We should continue, right? Elijah is active. He's saying we should continue. All right. Okay. Jude. Okay. All right. So let us just touch mathematics. Let's touch mathematics. Oh, who does 6 twos for whatever? Let's touch mathematics. All right. All right. All right. Never going back. Ah, my God. Chimamanda. Never going back. I love that. I love the energy. So let's touch mathematics, even if it's short, but let's touch something. All right. So for mathematics, the first question that we have there is on differentiation rather. The question said, differentiate. So if it's a comment, I'll ask me, I'm using my. Is that? Differentiate y equals to 3x squared plus 2x minus 5, all in brackets, raised to power 4. That's power rule and chain rule. Differentiate y equals to 3x squared plus 2x minus 5, all raised to power 4 with respect to x. These are practical examination questions with respect to x. Okay, okay. All right. So differentiating that with respect to x, option A, because of the constraint of the options, we just go straight to the calculations. Please pardon me on that. So differentiating this, you can see that this is a chain function. I am having 3x plus 2x minus 5 inside another function. It's a chain function. So how will I differentiate this dy dx? Because it's a chain function, the chain rule formula is dy du times du dx. First of all, I will say let u be equals to 3x squared plus 2x minus 5. So the u dx gives me 6x, 2 times 3, 6x. Meanwhile, the general form of the differential formula, if y is equals to x raised to power n, dy dx is nx raised to power n minus 1. Those of you that have been following me will get what I am saying. So what I did was 2 times 3, 6. 2 minus 1 is 1. Differentiate 2x, I have 2. That's the u dx. Now, putting u, substitute u into y. That means y is equals to everything inside the bracket was u. That is u raised to power 4. So the y du now will now be 4u raised to power 4 minus 1, which is 4u cubed. 4u cubed. So from there, I have dy du as 4u cubed. And 4u cubed is like saying 4 into 3x squared plus 2x minus 5 raised to power 3. Now, let us find dy dx. So dy dx is dy du times du dx. dy du is 4 into 3x squared plus 2x minus 5 cubed times du dx is 6x plus 2. So you can see there with me that my answer is out. That means I will use 6x plus 2 and multiply 4. So my answer will be what? 24x plus 8 into 3x squared plus 2x minus 5 cubed. What happened? 6x plus 2 is a term on its own multiplied 4. So that is 4 times 6x, 24x, 4 times 2 is 8. So that gives me dy dx. That gives me dy dx. That gives me dy dx. All right. Let's still touch something else on differentiation. Let's touch something else on differentiation. And that question will be, so I don't know if there's any question so far. I don't know if there's any question so far. Huh? This is the answer. Okay, I don't think I have access to the um mm. Answer is option C. So is the question on the screen? Another way you can write this is 4 into 6x plus 2. How I got 24x plus 8 is 4 times 6x, 24x, 4 times 2 is 8, into 3x squared plus 2x minus 5 all cubed. So you can see that the answer is C. Yes. Yes. All right. Let's move to the next question. That question is on quotient rule. Any question in the comment section? Okay, so let's move quickly to quotient rule. And the question came like this: find dy dx if y is equals to x squared all over sine x. This is a quotient. Question. In quotient rule, dy dx is given as plus v du dx. So what's my u? My u is x squared. What's my du dx? My du dx is 2x. What's my v? My v is sine x. What's my dv dx? My dv dx is, if I differentiate sine x, I will have cos x. How do I apply quotient rule here now? Quotient rule apply will be minus u, that's minus x squared times dv dx. dv dx is cos x plus v du dx. What is v? V is sine x times du dx. Du dx is 2x all over v squared. I forgot to include that. Thank you. I forgot to include that. That in quotient rule, I must always have v squared. Yes, v squared. All over v squared means all over sine x all squared. So my answer will be minus x squared cos x minus x squared cos x plus sine x. Sine x times 2x is not sine 2x squared. It is 2x sine x all over sine x all squared is something as saying sine square x. I hope you know that minus x squared cos x plus 2x cos sine x is something as 2x sine x minus x squared cos x. So a more proper form of representing that, this is equals to 2x sine x minus x squared cos x all over sine square x. Why? If I say minus 2 plus 5 is something as 5 minus 2. That's what is happening here. Minus x squared cos x plus 2x sine x is something as 2x sine x minus x squared cos x. So the answer that fits into the option that fits into the answer is option A. Fits in there. All right, let's look at the application of differentiation to gradient of a curve. Question 3. In this application, this question said, find the gradient of the curve. Find 2x cubed minus 5x squared plus 3 at the point x is equals to 2. At the point x is equals to 2. A, is it 4? B, 14, 2. The first thing we'll do is gradient means dy dx. Differentiate this 2x cubed, that gives us 6x squared. 2 minus differentiate 5x squared, that's 10x. Differentiate 3, that is 0. Now, let us find dy dx at x is equals to 2. At x is equals to 2, it is 6 into 2 squared minus 10 into 2. That becomes what? Huh? There's no plus. In where? There is no plus. Yes. Okay. That person that said that there is no plus in quotient rule, what's his name? Elijah. Elijah, how can you say that there is no plus in quotient rule? Quotient rule says minus u dv dx plus v du dx all over v square. There is plus. Another way you can write quotient rule, Elijah, another way you can write quotient rule is v du dx minus u dv dx all over v square. So it's the same thing. So Elijah, I think this is a formula that you know. This is a formula you're more familiar with. It's the same as this one. At the end of the day, when we came here, we changed it. So it's the same thing. So Elijah, please take note of that. Take note of that. Let's proceed. All right. So at x is equals to 2, from this quadratic equation that we're looking at, this is 6 times 2 square. 2 square is 4 minus 2 square is 4. That's minus 20. 6 times 4 is 24 minus 20. So dy dx, which is a gradient at x is equals to 2, is 24 minus 20, which is 4. So the answer is A. The answer is A. What did you change? Okay, 610. Yeah. Is it back?
It's back. It's back.
Alright. So I believe the audio is back now. Please, can you confirm for me if the audio is back now? I can't hear from you. Okay, okay. Udo62 just confirm for me that the audio is back. All right, all right. Udo62, thank you so much for that confirmation. So I can move on. So from where I stopped, yes. From where I stopped, when we found x has 2 and we confirmed that this actually has a maximum value because we did the second derivative, and the second derivative gave us -2. Now, from there, we were able to finding x as 2, use the value of x as 2, go back into the value of y to find the value of y. So 4 into 2, that gave me 2 square. So 8 minus 4, 2 square is 4. That gave me 4. So this is what happened from where the audio was being cut short. From there, we got here as y as 4. Remember the coordinate y? The correct answer is 2 and 4. So the option was A. If you cannot see the options on the screen, don't worry about that. Our solvings, our procedures, we are good to go. Diana Basi, thank you so much for being here. All right, so let's go to the next question. 62 is telling me to go to the next question, and I want to stop here, but 62 just injected me with one energy like that. I don't know where he got it from. Let's move to the next question. Let's move to the next question. The next question, that's at B, question number 5, that spoke about indefinite integration. Indefinite integration. All right. So if you can see the question on the board, on the screen, fine. If you cannot see the question on the screen, not a challenge at all. So from here, I would say the question said evaluate integral 4x cubed minus 6x squared plus 5 with respect to x. Evaluate this with respect to x. Now, take note that in integration, if I integrate x raised to power n with respect to x, what I mean is that I would say n plus 1 all over n plus 1 plus c. I must always add the constant of integration to the I must always add the constant of integration. That's the c I'm adding. Or you can say x raised to power n plus 1 all over n plus 1 plus k. All right. So anyhow you want to do that, that still gives you that. So from there, in this question, it's a very cheap one. It's not a function, it's not a chain function. So I'll integrate it directly. So integrating this will become 3 times 4 raised to power x cubed plus 1 all over 3 plus 1 plus, look, it was not plus, minus 6x squared raised to power 6x squared plus 1 all over 2 plus 1 plus, if I integrate 5, what I'm going to have will be 5x. And then I'll add my constant plus k. This will now become what? 12x raised to power 4 all over 4 minus 6x raised to power 3 all over 3 plus 5x plus k. So this will now become 4 goes here, 1, 4 goes to 12, 3. So I have 3x raised to the power 4 minus 2x raised to the power 3 plus 5x plus k. So I believe you can see that now. So let's look at that very well. Do you see what I did there? This is not it, though. This is not it. Look at this first term. That's not it. I was trying to differentiate inside. So for 4x cubed, it's going to be 4x raised to the power 3 plus 1 all over 3 plus 1. Yes. N plus 1 all over n plus 1. So that's what it's supposed to be. So it's supposed to be 4. X raised to the power 4 all over 4. Yes. 4 cancel 4. That goes. So this is 6 raised to the power 3 all over 3. This is 5x. Some people are wondering, how? How is it possible for 5? 5x raised to the power 0. 5 is anything at 5x raised to the power 0. This 5 is anything at 5x raised to the power 0. So I'll do what? I'll add 1 and divide it by 0 plus 1. So this is 5x raised to the power 1 all over 1, which is 5x. That's the answer. So having that, my answer becomes x raised to the power 4 minus 6x cubed divided by 3 is 2x cubed plus 5x plus k. All right, so the correct answer is B. If the answer is there for you in the option, you can see the answer, the options. The correct answer is B. So the correct answer being B, minus 2x cubed plus 5x plus k. The options use C. You can decide to use C. You can decide to use K. Any one you decide to use. All right. Are we still there? Is there any question before we proceed? Who does 6 twos? Go back, sir. Go back to what? Okay. I saw. Yeah, okay. I've already corrected it. Who does 6 twos? I've corrected it. Yeah. So we're still on, right? Okay. So we proceed. Okay. It will interest me to treat one more question on definite integration. I'll give you an assignment. Or nah, let me treat number 6. Let's move to number 6. Integration by substitution. That question said find 2x into x squared plus 1 raised to the power 4. Find the integral of x squared, 2x into x squared plus 1 all raised to the power 4. This is a chain function. We are going to use integration by algebraic substitution. Using algebraic substitution, we will now say that let u be equals to what? X squared plus 1. Immediately find the u dx. The u dx is what? 2x. You may be wondering, why is it that we are integrating and now we are doing differentiation? Why are we integrating and doing differentiation at the same time? Now, from here we can say that differentiating this du dx gives us 2x. That means that the u is given as 2x dx. 2x dx. There are two ways we can do this. We can quickly, from here, we can quickly replace 2x dx in the equation. Replace du. Let me not use the word replace. Let me use substitute. Substitute 2x dx for du, and x squared plus 1 for u. What does that mean? It means that integral of 2x into x squared plus 1 dx is the same thing as saying integral of 2x dx into x squared plus 1 raised to power 4. In fact, I prefer putting it this way. Anywhere I see u, anywhere I see x squared plus 1, I'll put u. So see x squared plus 1, I'll now put u. So this is 2x u raised to power 4. This is u raised to power 4 dx. And anywhere I see 2x dx, I'll put the u. So this is something I'm saying integral of u raised to power 4 dot 2x dx, which is what? Integral of u raised to power 4, 2x dx. Anywhere I see 2x dx, I'm going to put what? Du. So integrating that with respect to u, I will now have that integrating u raised to power 4 with respect to u will give me what? It will give me u raised to power 4 plus 1 all over 4 plus 1 plus k. That means what? U raised to power 5 all over 5 plus k. That means what? Remember what your u was? X squared plus 1 all over 5 plus k. X squared plus 1 all over 5. Remember u raised to power 5? So all raised to power 5 divided by 5 plus k. That will be my answer. Another way you can solve this, from the u is equal to 2x dx, you can say that make the x equal formula. If you make the x equal formula, you have that du is equal to 2x dx, divide both sides by 2x, divide both sides by 2x. 2x cancel 2x. So you can see that the x is equals to du all over 2x. Dx is equals to du all over 2x. Replace x squared plus 1. Replace x squared plus 1. Is it? Anywhere I see the x, I'm going to put du over 2x. Replace x squared plus 1 with u. That's substitute. And substitute dx equals to du over 2x. All right, let's go. If we go, this will become that integral of 2x into x squared plus 1 dx. This will be equal to integral of 2x. This is what? U. Oh, remember this was u raised to power 4. Sorry, u raised to power 4. In place of the x, I will now put du all over dx. Have you noticed du all over 2x? Have you noticed that 2x will cancel 2x? So this equals to integral of u raised to power 4 du. So you can see the same thing. U raised to power 4 with respect to u. So this is now u raised to power 4 plus 1 all over 4 plus 1 plus k, which is u raised to power 5 all over 5 plus k, which is equals to u, don't forget what u was, x squared plus 1 all power 5 all over 5 plus k. You can use c as your constant. You can use k as your constant. All right. At this point, we have made a reasonable amount of progress. We have made a reasonable amount of progress. Ah, Elijah, thank you so much. Thank you so much. So you can see from this point, you can see two methods. You can see two methods which you can use, and you can still get here. You can see this method you can use, and then you can still get here. At this point, I wish to give you an assignment. My WhatsApp group, my WhatsApp, DM me on WhatsApp. Let me see if it's correct. DM me on WhatsApp personally and drop your answer. Let me see if it's correct. Who knows? There could be a prize for the winner, for the person that gets it correctly. All right. So at this point, at this point, let's see the assignment. The assignment is going to be question 7, I think question 7 to question 8. So check the remaining 2 questions that I have left. If it's possible to project it, you know. I did question 6, question 7 and 8. Yes, 7 and 8. All right. So, if you have so I'll project, all right, says evaluate question 8 says evaluate integral of sine 3x d. Is it on the screen for them? Okay. So the options are there on the screen. You can pause it and write down the options to guide you to solve this. Here on the screen too, you can write the options to guide you. Yes. So these are the 2 questions with your assignment. Please, if you solve it, DM me on WhatsApp just so that I can construct if your answer is correct. Thank you so much for staying to the end of this class. Despite the challenges, despite the network glitches, despite everything, you still stayed to the end of the class. Thank you so much. Thank you so much. Chop knuckles, one closer for that. So if you did the assignment, please come to my DM on WhatsApp and drop your solution. You can just snap it and drop a solution so that I can view it, so that I can know. Yes. Thank you so much. Thank you so much for staying to the end of the class. Thank you for rooting for me. Thank you for rooting for me. If you are among those that are on our on-site classes, you know that we have an all-day chemistry class on Monday, 6th of April, starting from 9 a.m. in the morning till 4 p.m. in the evening. So see you next week. And just to remind you, this is an Easter period. Happy Easter to you. Thank you so much for staying to the end of the class. God bless you. God bless you. See you. See you.